Hey, good afternoon. It's a gorgeous afternoon here in the Bay Area. So here's another video for sections 5.5. It's part 2. And welcome back. So for those who finished watching the previous video today. So this one is going to be a lot more rigorous compared to what we have for the part 1. Okay, so we'll take a look at that. So again, it's all about using the U substitutions. So anytime they deal with the integrand, so any kind of complicated rational, it's like the combinations, composition functions, integrals with rationals, inner function with tricks. So you got to be really careful and try to slow things down so you know what to do. It's all about the setup. If you got to set up right, everything else, it just go through it. Okay, so now let's take a look at this. So U would be considered, well, either the denominator or the numerator. So you're trying to set U as the denominator, U prime would be considered 2x. So according to the function here, there's no 2x. So what we need to do, we want to set that U as the inverse of tangent of x. So that means U prime would be the derivative of tangent, inverse of tangent of x. As you may notice, derivative of inverse of tangent of x will be considered 1 over the quantity of 1 plus x squared. And then, don't forget, chain rule, dx. So that's something we talked about for the previous chapter already, derivative. Okay, so now let's put in that U prime. So for the top, we have U. And then also 1 over 1 plus x squared dx, then that'll be U prime. So everything is given already. So this one is not that bad. Okay, so integrated, so we do have U squared over 2 plus constant C. Okay, and then you want to unplug. So once you unplug, so we do have inverse of tangent of x, all over 2. And then don't forget, quantity squared plus constant C. So this one, again, it's an indefinite integral, so there's no boundary involved. For the definite integral, we'll talk about that later on today. Okay? So now let's try the next one. So for the next problem, we do have sine of natural log of x times 1 over x dx. So this one, there's so many functions involved here for the compositioning. Inner, outer. Okay, so remember that what we talk about in Algebra 2 and Pre-Cal, it's like FOG, or the FG of h of x, or g of h of f of x, things like that. So now, inner functions, so it looks like this one would be considered natural log of x, because that u prime is also given as part of the integrand here, which is 1 over x dx. So that's what we got already. And then rewrite it, so we got integrals from, well, there's no boundary, so there's no need to say that word from the boundary. So just putting that sine of u. So it's all about substitution right now. Subbing. And then sine of u. And then 1 over x dx would be what? U prime. And then integrals of sine of u, which is negative cosine of u. Okay? And then plus constant c. And don't forget, unplug. So negative cosine of natural log of x, and then plus constant c. So it's not that bad if you know what to do with the setup here. So the rest of this, it's pretty straightforward. So now, what about for I and j? Okay, so for I and j, take a look at that. So for I, we do have integrals of e to the power of x over the quantity of e to the power of x plus 1. So that means u would be considered e to the power of x plus 1. Because that u prime is also given here on top. E to the power of x dx. Rewrite it, so we have 1 over u. Okay, this one is given already, u prime. So integrals of 1 over u, we did that earlier. So it's natural log of absolute value of u plus constant c. So natural log of absolute value, e to the power of x plus 1 plus c. Okay, so it's not that bad. So now, what about the next one? So the next one, we do have 1 sine of x over the quantity, 1 plus cosine square of x. So obviously, the bottom part would be u. Okay, let me use a better marker. So the bottom one here. So 1 plus cosine square of x. So u prime. So that one should be considered 2 cosine of x, and then derivative of this negative sine x. But you'll find out that there's a problem here. 2 cosine of x, negative sine x. We do have sine x already, but we don't have 2 cosine of x. Well, for the constant, if that's a missing constant, we can make it up. But if that's a missing function, we cannot make that up. So that means there's something wrong with the setup here. So instead of using u as 1 plus cosine square of x. So let's change the setting here. So let's change the setup. So let's say that u just consider cosine of x. Then u prime, and that one should be given. Right here, sine x. It's negative. Well, negative sine x. So we're still missing that negative 1. Well, that's a missing constant, which is totally fine. So we just make it up. And then outside, we need to multiply by negative 1 as well. And now let's just rewrite it. Let me erase this part right here. So rewriting it, so we have negative 1 integrals negative sine x dx would be u prime, which is fine. Yes, u prime, we just want to separate it out. So we got 1 on top, because that things that get canceled here is just 1. And then denominator, just 1 plus u squared. What do you guys notice about the integrand now? Does that look kind of familiar to you? So integrals of 1 over the quantity of 1 plus u squared times u prime. Guess what? This one it's negative times negative 1 times inverse of tangent of u plus c. So this one is quite similar to what we did earlier for problem G. Okay, so again, this one is negative 1, so let's just put in negative. Unsubstitute, so we have negative inverse of tangent of u, which is cosine of x. And then plus constant c. And that will be the final form. Okay, so now the rest of this is getting more complicated. It's similar to what we got for I. Again, got to be careful with the way you set it up. So whatever the problem, whatever the expression that you have for u prime, it should be given, the function should be given either in the numerator or the denominator for the integrand. So for this one here, so let's say u equals 1 plus tangent of t. So u prime, then that'd be derivative of 1, then that's 0. Derivative of tangent, which is secant square of t. And for those who might be wondering, we don't have secant right here. But don't forget, this one is considered 1 over cosine square of t, which is the same as secant square of t. And dt, we just match out with dt, the chain rule. So now let's just rewrite it. So it's integral. So dt over cosine square of t, which is the same as this, u prime. So u prime, let's just put it separately. And then 1 over square root of this whole quantity. So that would be considered u to the power of negative 1/2. Again, 1 plus tangent of t, that's just u. So u to the power of 1/2 down the bottom is considered u to the power of negative 1/2 on the top. U prime. So integrate it, so we do have u to the power of 1/2 divided by 1/2, so multiply by 2, and then plus constant c. And then unsubstitute, so we do have 2 times u. So u, which is 1 plus tangent of t, the whole quantity to the power of 1/2 plus c. And that's the final form. Okay. Now, what about for L? Okay, the next problem. So sine of t times secant square of cosine of t dt. So inner function is pretty obvious, so which is cosine of t. Okay, so let's just set that up. So u will be cosine of t. And then u prime, which is negative sine t dt. Okay, so we're missing negative 1 here, so multiply negative 1 inside, outside. So rewrite it, so negative 1 times the integrals of secant square of u times u prime. So integrals of secant square of u, which is considered tangent of u. So it's negative tangent of u plus c. So eventually unplug. So it's negative tangent of u, which is cosine of t, so tangent of cosine of t. Again, it's the inner functions for cosine of t, and then plus constant c. Okay? And then for m, so that one is also quite obvious. So u would be considered, well, again, this one got to be a little bit careful. So we try to set this one as u for 1 plus x to the power 4, then the derivative would be 4x to the power 3. The power we have here on top, it's linear, so we cannot just use that u as the denominator. So for u, let's just rewrite the expression first. Let's put it as x over 1 plus x squared, and then squared. Okay, so this one is a little bit special, because sometimes you need to play around with the pattern. So you don't recognize the pattern here, so one way doesn't work, so you have to try another way. Okay, so it's the power of another power. So that means u will be considered x squared. And then u prime, which is 2x, and then dx. Compare and contrast, u prime, we got dx, we got x already. We're missing 2 right here, so multiply by 2. Outside, multiply by 1/2. Okay, so now let's just rewrite it. So this one eventually is going to be written as 1 over 1 plus u squared. Again, x dx, and then the 2, we do have that already, which is considered u prime. Don't forget to bring down the 1/2 here. It's part of it. Okay, so 1/2. Okay, so the 2, the 1/2, got to be consistent. And now, again, the pattern for this, back to what we did earlier, integrals of 1 over quantity of 1 plus u squared, it's inverse of tangent of u. So it's 1/2 times inverse of tangent of u plus c. And then eventually, rewrite it, unplug. So we got 1/2 inverse of tangent of u, which is x squared, and then plus c. Okay, so we're going to be careful with the inner functions, outer functions, and also the pattern that I need to simplify or rewrite. Okay, because that will change the whole thing a lot. And then for the last one right here on this side of the whiteboard, so let's take a look at this. And so we got x squared over integrals of x squared over the square root of 1 minus x. Okay, so you might be wondering, how do we set things up for this one? So anytime that I deal with a problem like this, so you got to be a little bit careful. Okay, so u, if that's 1 minus x, that means the derivative would be just -1. But -1, well, we don't have that. There's another variable on top. Okay? Well, let's just set it like the original way first. So u would be 1 minus x. So u prime, it's -1. Derivative of -x, -1 dx. And then negative, that's what's missing here. So we multiply by -1 here, multiply by -1. So how do you deal with that x squared on top? So one thing that we can do, we can always solve for x in terms of u. So u equals 1 minus x, so that means x is the same as u minus 1 minus u. Okay, 1 minus u. And then x squared, square both sides, so x squared would be 1 minus u, quantity squared. So now let's just rewrite it. So we got -1 times the integral, -1 x squared, which is considered 1 minus u, quantity squared, over, so this one is just replaced by u, so u to the power 1/2, and then dx. -1 dx, we can just replace that by du, u prime. So here's the new integrand, so we're getting right now. But now, how to expand it? So the top part right here, we can use the binomial expansion. So it's 1 minus 2u plus u squared over u to the power 1/2, and then times du. Okay, we're going from right to left this time. We're going this way. And now we want to separate it out term by term. So once you separate it out term by term, we do have -1 integral of 1 over u to the power 1/2. It's easier to integrate it with term by term. And then 2 over u to the first power over u to the power 1/2. So we got 2u to the power 1/2. Because I have the exponent division, so you subtract the exponent. And then u squared over u to the power 1/2. We do have u to the power of 2 minus 1/2, 1.5, 3/2. Don't forget about the indicator, du. And now we just want to integrate this. So it's negative, well, it's going to be negative the whole quantity. So u to the power, this one is just like 1 over u to the power 1/2, which is u to the power negative 1/2. Power rule. So using the power rule, we do have u to the power 1/2 divided by 1/2 multiplied by 2 minus 2u to the power of 3/2 multiplied by 2/3. So it's going to be 2 times 2/3, which is 4/3. And then plus u to the power of 5/2. This 3/2 plus 2 over 2, 5/2. Multiplied by 2/5. And then the whole quantity of this, combined it with the constant c. So eventually, the integral, the definite integral will be written as negative 2 was u again, right there, 1 minus x to the power of 1/2 minus 4/3, negative, negative, positive, plus 4/3, so 1 minus x to the power of 3/2, and then plus continuations, 2/5, u, which is 1 minus x to the power of 5/2, and then finally plus constant c. So we do have 1, 2, 3, 4 terms. Okay, so that one is a lot more rigorous because this one here, so you need to use the pattern, and also you need to find out what x is in terms of u, and then you need to square both sides. So this one is the key step. If you're being able to do it, so that means the rest of this we can integrate it separately, term by term. Okay, so now let's see what else that we have for this part of the video today. So it's a little bit long, and also it's a little bit tedious for a certain problem. So finally, we're getting to definite integral. So definite integral, that means we want to find out the exact value. And for those students might be wondering, how do we find exact value for the definite integral with the use substitution technique? So it's the same strategy. Back to the formula we have. We need to change the boundary anytime that you change the functions, the expression. So u for this one would be 4 plus 3x. So u prime, so that would be 3 dx. So dx, we have that already. The 3, we need to make that up. So times 3, outside, 1/3. So now it's written as 1/3. Still consider integral from 0 to 7. This one here, which is u to the power of 1/2. 3 dx, which is what? U prime. Now, if you try to do it this way, that means eventually you want to plug everything in terms of x. But now, let's change the boundary. Since we do know that u is the same as 4 plus 3x. So for x equals 0, plug in a number. So that means u would be considered 4 plus 3 times 0. So then that'd be 4. And then if x is 7, plugging that to u expression, so we do have 4 plus 3 times 7. So 7 times 3, 21. 21 plus 4. So 25. So we change the boundary. So from 4 to 25. So you just change the boundary. That means there's no need to unplug at the end. Okay? So it depends on which way that you prefer. And now let's just integrate it. So power rule. So we do have u to the power of 3/2 times 2/3 times 1/3. So times 2 over 9. It's 1/3 times 2 over 3. So it's 2 over 9. And then don't forget about the boundary. It's the definite integral. So it's from 4 to 25. And using that part 2 of FTC. So 2 over 9 multiplied by f of b minus f of a. So 25 to the power of 3/2 minus 4 to the power of 3/2. You guess what that is? So root 25, then that'll be 5 to the power of 3, then that'll be 125. Minus square root of 4, then that'll be 2 to the power of 3, 8. So 125 minus 8, then that'll be 117. So we got 2 over 9 times 117. So thinking about that, anything that can be reduced, yeah, looks like 9 goes into 117. How many times? 13 times. So the result would be 26. Okay, so check that. So that means the area under the curve from 0 to 7 for this type of functions. So eventually it's going to be 26. So that's just one of those problems. So now what about for B? So that one is quite similar. Again, it's all about the U substitution with the boundary that we have to change. So for U, then that we consider x squared, U prime, 2x, dx. Compare and contrast, we got dx, we got x already, but we're missing 2. So make up that number, multiply 1/2 outside to even that number out. And then change the boundary, so for x equals 0, we got u equals 0. For x equals pi, we got pi squared for u. Again, just like a direct substitution for this. Rewrite it, so 1/2. So integrals from lower bound to upper bound, pi to pi squared. And then 2x dx, that's given already, u prime. And then cosine of u. Integrate it. So integrals of cosine of u. So we do have sine u. 1/2, just leave that outside. So this one, it goes all the way from pi to pi squared. And then plug in that number, f of b minus f of a. So 1/2 times sine of pi squared minus sine of pi. So sine of pi squared, we don't know exactly what that is, which is fine. So sine of pi, that's just nothing. So 1/2 times sine of pi squared. And that'd be the final value. Okay. So for the rest of this, they're quite similar, but you got to be careful with the pattern, the way you set up that u prime, and also the boundary. So the key step for the definite integral is changing the boundary if you don't want to unsubstitute at the end. Okay, so now what about for this one? So inner functions, so let's say pi t, u prime, then w pi dt. So we got dt already, we're missing pi. Outside, multiplied by 1 over pi. So for x is 1/6, so that means u is pi over 6. For x is 1/2, that means u is pi over 2. Cosecant and cotangent, okay, we'll get back to that one. So integrals of, well, 1 over pi, it's outside. Lower bound, upper bound, right here, pi over 6, all the way to pi over 2. It's always from the least to the greatest. If that's the other way around, that means you want to flip the integral. You want to flip the boundary over and change the sign to its opposite. And then, so what we got here is cosecant of pi t, so cosecant of u, cotangent of u as well. So pi dt, which is u prime, just an indicator, or du, either way. For those who are getting used with that du. If someone can now tell me about the integrals of cosecant and cotangent, it is negative cosecant. So negative 1 over pi, cosecant of u, because cosecant, derivative of negative cosecant would be cosecant of u, cotangent of u. And then from pi over 6 to pi over 2. Again, I'm going from right to left, so put it into f of b minus f of a. So we got cosecant of pi over 2 minus cosecant of pi over 6. Back to the unit circle, what's cosecant of pi over 2? That's 1, right? Because sine of pi over 2 is 1, so the reciprocal is also 1. Cosecant of pi over 6. What's sine of pi over 6? What's sine of 30 degrees? Sine of 30, it's 1/2. Reciprocal of that is 2. So it's 1 minus 2. So negative 1 times negative 1 over pi, which is 1 over pi. Again, we're going from right to left. Then that'd be the area under the curve for this. So for those, you might be saying that, well, once you integrate it, this whole thing eventually is going to be 1 times 1 over pi. Just 1 over pi. Okay, so now what about for the next one? So the next one, it's a little bit weird. For those you might be wondering, is any like a typo, anything that's missing here? So nothing is missing here, but I just want to go back to the one of the formula that we talked about for the previous video, part 1 of 5.5. Anytime that you deal with the odd function, let's say that you want to integrate, find the area under the curve, or integrate it from negative a to a for the odd function. So the result, guess what? It's always 0. Well, check it out. The integrand here is not the odd functions. We got even, even, even. What about for sine of x? Sine of x, that's odd. So let's say you've got 2, 0. This one here, 6, even. If that's an odd function, let's consider 1. What's 2 plus 0 plus 6 plus 1? Which is 9. What kind of number is that? Odd. So that means this 1 is an odd function. If that's an odd function, there's no need to integrate it. If that's a symmetrical, from negative to positive. So this one, the result, it's always considered 0. Reason, it's an odd integrand. That's why there's no need to integrate it. So just using that formula. Okay, so now what about the last 2 problems here? So let's finish this. So back to the use substitution technique. Excuse me. So you can check that. It's a little bit off. Okay, right here. Good. So we do have a squared minus x squared. So u prime, guess what u prime is? Then that'll be negative 2x, negative 2x. Again, a, b, and c, those are just arbitrary constants. So we got x dx already. So we need negative 2. Outside, we need negative 1/2. So integrate it, negative 1/2. And also change the boundary. So for x is 0s, so u would be considered a squared. If x is a, that means u would be considered 0. So that means this one we're actually going from a squared to 0. For those you might be wondering, this one would be kind of weird. Well, let's just keep it like that first and see what happens next. So x, that's part of the u prime. So we got negative 2x dx already, so then that'd be u prime. So a squared minus x squared, then that's u, so u to the power of 1/2. So anytime they see the lower bound, it's greater than the upper bound. That means you want to flip it over. By the time you flip this one over, guess what you have to do? You want to change the integrand from its negative to positive. If that's positive, you want to change that to its negative. So it's negative here, so negative times negative, positive. So positive 1/2. The reason why that is because we flipped the boundary over. And then this one would be u to the power 1/2, u prime. It's the same expression. And now let's just integrate it. So we do have integrals of u to the power 1/2, which is u to the power of 3/2 times 2/3, and then times 1/2, bounded from 0 to a squared. Again, using FTC part 1, so we do have 1/6, well 1/3 actually, cross cancel. So 1/3 times a squared to the power of 3/2. Minus, well this one is just 0. So 2 and 2 got cross cancel, so we got 8/3. So it's 8/3 over 3 for the result. Okay. So now the last one, finally, we're getting to the last one. Oh, you know what? This one's supposed to be e to the power of 3. Okay, so just cross that out. Okay, so now let's. So I need a little bit more space here. So finally, so guess what u is for this? That's right, natural log of x. So u prime, 1 over x dx. Hey, guess what? dx, 1 over x, they're already given. Okay, so change the boundary. So when x is e, So u would be natural log of e, which is what? 1. And then when x is e to the power of 3, so u would be natural log of e to the power of 3, which is 3. So rewrite it, integral from 1 to 3. So dx over x, so we do have u prime. And then 1 over square root of natural log of x. So then that would be considered u to the power, this u is natural log of x, to the power of negative 1/2. Gotta be careful, it's down at the bottom, so you need to convert that to the negative exponent. And then integrate it. So u to the power of negative 1/2. So integrals of u to the power of negative 1/2, which is u to the power of 1/2, times 2, from 1 to 3. Again, f of tc part 2, so 3 to the power of 1/2, minus 1 to the power of 1/2. So we got 2 times root 3, minus 1. 2 times the quantity of root 3 minus 1. I mean, you can distribute if you want, or just leave it like this if you want to. Doesn't matter. Either way is fine. Okay? That's it. Okay, so thank you for watching the video today. Again, any questions, any comments? So make sure that feel free to put it on the YouTube channel. And also refer to any people if they want to learn about calculus. See you guys next time.